Welcome to This Explainer, where we're going to take a super dense, kind of intimidating spreadsheet of raw data and turn it into a pretty compelling story about machine reliability and maintenance efficiency. If you've ever stared at a massive factory floor or honestly managed any complex system and just wondered, how on earth do they keep everything running smoothly 24/7? Well, you are in exactly the right place. Let's jump right in by asking a really fundamental question. How do we actually quantify the health and resilience of our complex machinery? I mean, sure, it's incredibly easy to just eyeball a machine and say, yeah, it's running good or looks bad. But we all know that in the high-stakes industrial world, subjective feelings absolutely do not cut it. We need hard, actionable numbers to actually guide our operations. So here is our roadmap for today. We'll be hitting 6 key areas: the cost of downtime, decoding Mtbf and Mttr, looking at a month of machine data, calculating uptime, calculating recovery, and finally wrapping up with why these metrics matter. All right, section 1, the cost of downtime, because as we know, every single minute counts in manufacturing. Look, we all know machines are eventually going to break down, right? That's just reality. But here's the thing. Downtime is not just bad luck. It's literally data waiting to be analyzed. Every time a gear jams up or a motor overheats, that machine is sending us a critical signal. We really have to track the chaos if we ever want to control it. Moving on to section 2, decoding Mtbf and Mttr, which is essentially the language of reliability. Before we get into our case study, let's just quickly align on our definitions. First up is Mtbf, or mean time between failure. This is basically our uptime. It's the baseline metric that quantifies exactly how reliably the machine runs before hitting a snag and breaking down. Second is Mttr, which stands for mean time to repair. And this tracks our agility. When a breakdown inevitably happens, this measures the exact speed of your maintenance team's response, how fast they can diagnose the issue and get production moving again. Which brings us to section 3, a month of machine data, focusing on our January 2026 case study. You know, theory is great and all, but actual production spreadsheets, that's where we find the truth. What we have here is a calculation sheet tracking a single machine's performance over 31 days in January 2026. Each row is a single day. And if you notice, the planned time lists 1,440 minutes for every single day of the month. That translates to exactly 24 hours. So this machine is scheduled to run continuously, nonstop. Right next to that, we're tracking the machine downtime and the specific reason for any time loss. Now, as you scan down the list, you'll see most days just say, okay, with 0 downtime. But it's those few days with actual recorded minutes that tell the real story we're digging for today. To kind of distill the chaos of that full sheet, we can extract just the 6 specific incidents that caused our 430 minutes of total downtime for the month. The issues really range across the board here, from a 45-minute tool change on January 3rd to a burnt coil, all the way to some pretty severe vibration problems that cost us up to 2 hours in a single day. So that's 6 distinct events, leading to a cumulative 430 minutes of lost production. Let's move into section 4, calculating uptime or Mtbf. Let's do the math for reliability. Finding the Mtbf is actually a super simple 2-step process. Step 1, we take the total planned time and subtract the machine downtime. That gives us our true operating time. Then, step 2, we just divide that operating time by the number of failures. Easy, right? So let's go ahead and plug in the actual numbers from our sheet. We take our total planned time for the entire 31-day month, which comes out to 44,640 minutes. We subtract those 430 minutes of cumulative downtime we just looked at, and boom, we arrive at 44,210 minutes of actual, true operating time. That number right there, that is the real engine of productivity for January. Now for step 2. By dividing that 44,210 minutes of operating time by our 6 specific failure incidents, we reveal an Mtbf of 7,368.3 minutes between breakdowns. Having this number is absolutely crucial because it gives the engineering team a precise mathematical baseline to measure against when February rolls around. Okay, section 5, calculating recovery, or Mttr. This is all about measuring our bounce back. The formula for mean time to repair requires us to simply divide our total downtime by the number of incidents. It's really just straightforward averaging. We basically just want to know, on average, how long does a typical repair ticket stay open? So looking back at our month's data, we take the 430 total minutes of downtime, divide that by those 6 failures, and we get an MTTR of 71.667 minutes per repair. This means that when the alarm sounds and the machine halts, management knows for sure they can expect an average delay of just over an hour before the whole shebang is up and running again. Finally, Section 6, why these metrics matter. Let's talk about turning these numbers into an actual strategy.
Because let's be honest, data without interpretation is pretty much useless, right? To put that calculated Mtbf into perspective, 7,368 minutes equates to roughly 5 straight days of flawless, uninterrupted operation between those relatively fast 71-minute fixes. And this tells a really powerful story. It tells us that we have a highly resilient machine running continuous 24-hour cycles for 5 solid days at a time, and it's being supported by a maintenance crew that acts swiftly and effectively the second parts do start to wear out.
And if we analyze the sheet a bit closer, we can actually spot patterns to improve that 5-day stretch. Like, did you notice how vibration problems caused our biggest daily breakdown spikes? On January 7th, vibration cost us 8.33% of that day's planned time. Then on January 18th, it happened again, costing us 6.25% of the day. This data is literally screaming at us that vibration isn't just some random fluke. It's a systemic issue. If the maintenance team were to focus their preventative efforts heavily on machine vibration next month in February, they could significantly increase that Mtbf metric. But despite those daily spikes, the broader data reveals an incredibly efficient system. By managing those failures quickly and keeping that MTTR hovering right around 71 minutes, total downtime for the entire month was kept to just 0.96%. I mean, think about that. Less than 1% of available time was lost. That is huge. Which leaves us with this final thought for today. Downtime really isn't some enemy to be feared. It's an incredible, untapped source of data. If you were to start rigorously measuring your own Mtbf and MTTR tomorrow, what hidden opportunities for efficiency do you think you'd uncover in your operations? What recurring vibration problems are secretly holding you back right now? Track the chaos, run the math, and you'll build a much more reliable system. Thanks so much for joining me on this explainer. Keep analyzing that data, and I'll see you next time.